First is this little transformation cheat sheet. So reflections are flipped. They're flipped over a line of symmetry. The rules for the ordered pairs, if you flip something over the x-axis, it originally was xy, and then it becomes, so this is what it originally was, and then it becomes x, the opposite of y. So it's the opposite of x. So you change y to its opposite. When you flip it over the y-axis, it's the opposite. So it starts out as xy, and then it changes to negative xy. So that x becomes the opposite. For example, my ordered pair was -2, (3), and I wanted to flip it over the x-axis, it would be -2, -3. If it was -2, (3), and I wanted to flip it over the y-axis, it would become 2, 3. Rotations are turned. These rules are a little bit trickier to remember. When you're flipping them 90 or 270, because a 90 and a 270 is a counterclockwise 90 is the same as a clockwise 90. A counterclockwise 270 is the same as a clockwise 270. So they kind of go together because based on where they flip. 180 is the easiest to remember, just both signs change. But for 90, counterclockwise 90, or clockwise 270, it becomes the opposite of y-x. So the two order pairs flip around. Same thing for the 270, but the y becomes the opposite, and then the x becomes the opposite. So those are just the rules to remember. All right, here are the 5 questions you got wrong on your last unit test. So it says the vertices A, -2, -1, B, -3, -2, -1, 3, and D was 0, 0, form a parallelogram. The vertices A, so notice they flipped. So it became -1, -2, 2, -3, 3, -1, and 0, 0 are the images of parallelogram after a sequence of transformations. Which sequence of transformations could produce the images from the pre-image? So it's this one. It's the reflection over the y-axis because and a 90-degree clockwise rotation around the origin. The reason it's not the one you chose is because a 90-degree clockwise rotation about the origin and then a reflection would have changed, also changed the signs. So it's the second one based on the rules. All right, Jason states that triangle ABC and RST are congruent. That's what that symbol means. Kelly states that the ABC and TSR are congruent. Which best describes the accuracy of the congruent statement? Okay, so congruent statements have to be in order. So if A matches up with R, they're saying in this one, A matches up with P, then S, and then R. However, these two triangles are equilateral or isosceles, so they're symmetrical. So it doesn't matter which order they go in because they're going to be the same. So that's why both statements could be correct. Because even if I flip the shapes around, it would still be congruent to each other. He then created 3 triangles, triangle X, triangle Y, and triangle Z. If Y is congruent to X, so we have triangle X, triangle Y, and triangle Z. So it's saying Y and X are congruent, and it's saying Y and Z are congruent. Therefore, X and Z also have to be congruent because it's a transitive property. If one is congruent to the other, and then another one's congruent to it, they have to be congruent to each other. Okay, triangle ABC is shown with 4 images that are each the result of a transformation of triangle ABC. There's ABC right here. For which triangle is one reflection necessary for the transformation to occur? So MNP, which is this one right here, would only need to be translated. It would need to be translated just right across. okay, which is why that would not be correct. This one would not be correct because LMKJ is also a translation. So it has to be GHI because that's the only one that is one reflection. Because if it was this one here, RSQ, or QRS, however you want to name that triangle, it would have to be two reflections, where these two other ones are translations. So the only one correct would be this one. All right, square ABCD is shown with 4 congruent images such that ABCD is congruent to FGHI, which is congruent to all of them. Basically, the statement just the same, all of them are congruent to each other. For which square is a reflection necessary to produce the transformed figure? So ABCD is right here. If it was reflected, it would match M, and A would match M, which is not true. A matches F. So that one would not be correct. This one down here, A and R. So it's saying that A would come first and R would come first, and then D and U. Okay, that's correct. B matches up with S, and C matches up, so it's got to be this one because it's the only one that has the letters in the correct order. It's really important that the letters match up. So A, B, C, D has to match F, G, H, I. So like, for example, F, G, H, I, that would work if it was a translation and was moved down. But since it's a reflection, it has to be this one.